So before we even get started, make sure you copy down the highlighted portion, okay? So you'll put it on pause. All right, you've copied all that stuff down. All right, I don't know if you remember back a long time ago when we had projects and you all had different parent functions. So if you remember, if you had the parent function f of x equals x, it made a line through the origin. And if you had x squared, it made a u through the origin. And you had x cubed, and it was the squiggle, and so on and so forth. Well, this is another type of function, and it's called a rational function. How do you know it's rational? The x is in the denominator, okay? Now, the other ones, you know, we call parabola, a cubic function. This rational function creates something called a hyperbola, okay? So when you graph the hyperbola, and it kind of sounds like parabola, because you'll see when I graph it, it looks really similar. So what it is it's two lines that look like they're about to touch the x and y axis, but they never do. They look like they're trying to touch the y-axis, but they never do. Now, a new word you're going to learn about that you're going to think is funny, but the word is asymptote. And what it means is it means that you're going to get close, 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 but never touch. And you will have a vertical asymptote and a horizontal asymptote. The vertical asymptote will be x equals 0, and the horizontal asymptote will be y equals 0. If you look at this graph, it looks like it's almost going to touch, but it's not. I don't know if you remember being a kid, a little kid, and your mom would say, don't touch it, and you get as close as you can. You're like, I haven't touched it, I haven't touched it, I haven't touched it, okay? Because in a sense, this piece of paper would be the asymptote, what you cannot touch, okay? What I want you to see, too, is that when I graph, when I graph the parent function, there it is in Desmos, okay? So if I move this over, you can see there's y equals x. Ignore the other stuff. Okay? All right, let's go back to the screen. Not as coordinated at all of that. So what I also want you to see is that there's also transformations. Do you remember when you were doing a parabola? Let's go back to the parabola, and I had y equals x minus 7 squared plus 3. This would be horizontal translation, 7 units right. And this would be vertical translation, 3 units down. But of course, you'd handwrite that stuff. That's exactly what this is. So what I want you to see is that whatever number is with the x is also the vertical asymptote, but in a sense, it'll be the vertex. You'll see. And whatever the horizontal asymptote is, that would be going there. So let me show you what I mean by that. If I go over to Desmos, let me minimize this. And if you look over here, let's see if I can make it bigger. It's not letting me very much. But if you look over here, let me erase this. I added sliders. So see how it says a equals 0? Let me put that back. There's the parent function, okay? And if you look at that, let me move this over a little bit more so you can see. If I move the a, look what's happening. It's moving to the left. Because it's always the opposite. See how this is positive? But it's moving to the left because it's not the straight shooter. The x is not the straight shooter. Let me see if I can get that back to 0. Close enough, right? Whatever. And then the b. The b is your y. So it affects you up and down. If you notice, if you look right along here, that's my horizontal asymptote. It's never quite approaching. See how that says 2.8? It's never quite approaching 2.8. So if I wanted to have the vertex of 3, 1, okay? That means I would have to go -3, and then 1. We get to 1. All right. If you look here, then there's the vertex, 3, 1. But if you look at the horizontal line, it's never quite touching at 1. See how it gets super darn close, but it doesn't actually touch. Okay? See how it says the decimal there? The y value never gets to 1. Okay? And then if you look here, the x value will never, ever get to 3. It'll get so darn close, okay? So you can use Desmos to help you. All right, let's go back and actually answer some of these questions now that we have the basic idea. All right, so they want us to do a lot of stuff. They want us to draw a rough sketch. They want us to state the asymptotes, the transformation based on the parent function, okay? So we know the parent function is 1 over x. So if you look here, it's with the x. If it's with the x, that means it's horizontal. So that means you would write horizontal translation 3 units right. But if you write HT3UR, I will mark it wrong. So you will write horizontal translation 3 units right. And there's nothing happening out here, so that's it. Okay? What would that mean the imaginary vertex would be? The imaginary vertex would be 3, 0. And remember, when it's with the x, it's not a straight shooter. Okay? So let's actually graph it. And of course, the value 3 is going to be kind of important. So I will have a vertical asymptote of 3. And there is no y, so it's going to have a horizontal asymptote of y equals 0. And when I'm graphing, it's always top right, bottom left. Unless there's a reflection, we'll worry about that later. So I just need to show that that almost approaches but doesn't forever. Almost not to the y-axis, over here to the 3. Always almost approaching, but not. Okay? I also think I need you to state the domain and the range, but I should have said that, so let's say domain and range. I shouldn't have made this so big. Whatever. The domain. Remember, domain is your x. So, hey, x can be anything in the whole wide world except for your restriction of 3. So I'm going to say all real numbers, but x cannot equal 3. And I don't need it in interval notation. This is fine. Okay? And then I'm going to say the range. Well, the range is based on the horizontal asymptote, which means it could be any any real number as well, but x, just kidding, y cannot equal 0. Okay. We also didn't actually state the asymptotes, sorry. So there's a vertical asymptote and there's a horizontal asymptote. The vertical asymptote is always your x. So x equals 3. You only write what it can't be when you're talking about the restrictions. And then the horizontal asymptote is y equals 0. Okay? Let's jump to number 3 because it just feels right. So, horizontal translation, not a straight shooter, 4 units left. Vertical translation, 3 units down. Okay? So I'm going to go VA, HA, domain, and range. I want you to see how all this stuff's related, okay? So x equals domain, all real numbers, but x can't equal. Well, what can't x equal? It can't equal -4. Why? Because when you set that equal to 0. See how they're related. Horizontal asymptote, y equals all real numbers, but y cannot equal. All right, the y is a straight shooter, -3. Okay, and the vertex, imaginary vertex, is -4, -3. So if I was to graph this, let me I took up too much space on that, sorry. -4, -4, -3, vertical asymptote, and then horizontal asymptote, top right, bottom left. Okay, let's go to the next one. All right, there is no horizontal transformation, so hold on, I have to sneeze. Sorry, I don't think I did. Okay, there is no horizontal transformation because there's no number, there's only a vertical translation. 2 units down, straight shooter, VA, HA, domain, range. X equals, Y equals. All real numbers, X cannot equal, Y cannot equal. Okay, X equals 0. So x just can't equal 0, because if you set that equal to 0, you get 0. Y, -2, -2, straight shooter. Now I'm going to graph it. X equals 0. Make the dashed lines. If you make it solid, I think it's part of the graph. And then down 2. Top right. Very bad. Bottom left. Okay? Last one. This one's different, and we'll get to that. So here, horizontal translation, 5 units right. Vertical translation, 2 units up. Now, because there's a negative, reflection over. Honestly, whether you say the x-axis or the y-axis, it'll still work, and I will explain that in a second. So y or x. You want reflection over x-axis? Great. You want reflection over y-axis? Great. But you don't need to say both, because then it's a double reflection and it never happened. Okay? Then let's do our VA, HA, domain, range. All real numbers. All real numbers. 2. X cannot equal, X equals. Y cannot equals, Y equals. All right, so that's not a straight shooter. 5, 5, done. Positive 2, 2, done. Now I'll graph it. So 5 and 2, vertical asymptote, horizontal asymptote. So when you get the negative, it's going to reflect over here. If you did this, this would be reflecting over the y-axis. So this would be over here. And then the one that was down here would be over here. If you were reflecting over the x-axis, this one would be down here, and this one would be up here. So what you can see is no matter what, it doesn't matter what you say, but this time it's top left, bottom right. Okay? Let's turn the page. This is your homework. Okay? Do the same thing I asked for on the previous page, and I think that's it for now. Oh, nope. We have the equations. Okay, so now I need you to get the equations. In order to get the equation, we need to figure out the VA and the HA. So if you look, I need to look, where is it almost approaching, but never gets there? X equals -1. Where is it almost approaching, but it never quite gets there? There. That means this is all real numbers, but X can't equal -1. All real numbers, but Y can't equal 2. I do want the equation, y equals 1 over. Remember, the x is not a straight shooter, but the y is. Done. Okay? Let's go to the next one. Okay? Vertical, let's see, vertical. It looks like it's almost hitting 5. X equals 5. And then it looks like it's getting close to 6. So y equals 6. Okay? That means the domain, all real numbers, x cannot equal 5. All real numbers, oops, y cannot equal 6. Sorry, you can't see that. Then I do the equation, y equals 1 over, not a straight shooter, straight shooter. Okay? Oh, and I forgot to state the transformations. Horizontal translation, 1 unit left. Vertical translation, 2 units up. Because it literally looks like it went to the left and up. Horizontal translation, 5 units right. Vertical translation, 6 units up. Okay? So your homework is going to be 3, 4, 5, and 6. But remember how we always said top right, bottom left? This one's top left, bottom right. So you have to know that when you're doing the equation, there's going to be a -1 on top. Okay? You could actually put a -3, a -10. There just needs to be the negative. Okay? So now you know your homework, and you will be ready for the next lesson.